In this example, we're asked what is the solution to the equation x squared equals 36? Well, normally when you solve equations, one of the most common ways is to do reverse order of operations. Getting rid of addition and subtraction first, which this equation doesn't have any addition and subtraction. Then getting rid of multiplication and division. Again, this equation doesn't actually have a multiplication and division, just a general process here. And then getting rid of exponents, which is the stage we're at right now. To get rid of exponents, you can use the opposite operation or the opposite of the exponent, but the property that we typically use in getting rid of a squared is the property that says that if we have x squared equals a, then x will equal plus or minus the square root of a, assuming a is greater than or equal to 0. Oftentimes you'll hear people say square root both sides. It's not quite the same thing as square root both sides, but that's what the property appears to make it look like. But if we do that, applying this property, we're going to have x equals plus or minus the square root of 36, which is 6. So solution for this is either positive or negative 6. You can write it out with the plus minus sign, or you can write it out x equals 6, x equals negative 6. Both are correct, and depending on the context or how you're requested for the answer, depends on which way you want to use. Okay, in this video we're asked what is the exact solution, which means no decimals here, to the equation x squared minus 15 equals 5. And you can see I already wrote down the equation down below. So to solve this is a pretty simple quadratic, as it only has x occurring one time, which means we can use reverse order of operations. Wow, please excuse my dear. Gotta hit myself in my head. So going through reverse order of operations, we're going to get rid of addition and subtraction first. We'll add 15 on both sides, giving us x squared equals 20. Now we would get rid of multiplication and division. There actually isn't any multiplication and division on this particular problem. So finally, we'll get rid of exponents using the property mentioned in the first example, which essentially amounts to square rooting both sides here, giving us x equals. When you do this, when you apply this property, you need that plus minus. You need the positive and negative solutions here. And then the square root of 20, well, the square root of 20 isn't actually a whole number, so I'm going to go off to the side here and break it down. The square root of 20, well, I know the largest perfect square that goes into 20 is 4. 20 can be broken into 4 times 5. Using one of the radical properties, we can separate that into 2 radicals since they're connected by multiplication. And then the square root of 4 is 2. The square root of 5 we can't actually do, so we leave it as the square root of 5. Since we're looking for exact solutions, we do not want to type it into a calculator to get the decimal approximation. Remember, you can also write out the answer as the 2 separate forms as well, 2 radical 5 and negative 2 radical 5. Either or is correct. I usually just use the plus minus. Okay, in this example, we're asked what is the solution to x squared equals negative 16? Well, normally we'd apply the property right away because there is no addition, subtraction, or multiplication, division. Applying the property, we would square root both sides here, giving us x equals plus or minus, but we have a problem. Right here, what's happening is we're square rooting negative 16. And if you remember, you can't actually square root negative 16. So that creates a little bit of a problem. And in Algebra 1, you would say that this is no solution, or no real solution. This video here is made for Algebra 2. In Algebra 2, we go on to talk about what are called imaginary and complex solutions. So I'm going to skip down here. At one point, someone has defined I to be an imaginary number, which is defined as the square root of -1. And by extension, I squared is defined as -1, which really isn't a huge deal for today or for this particular video, but will be in the future. So we're defining I to represent the square root of -1. Even though it doesn't actually exist, we're going to pretend it exists for this sort of situation. And it does actually have applications. The specific one that comes to mind is vectors. But for now, we're just going to be introducing it and just learning how to solve simple equations involving imaginary solutions. So going back to our example, now that we have that, we can go ahead and deal with this using complex numbers. We're no longer in Algebra 2 going to say no real solution. There is no real solution because the solution will be imaginary. However, we're more concerned about imaginary and complex solutions. So with the -16, we will separate it into -1 times 16. Then radical properties allow us to separate that into two separate radicals. And then the square root of -1 we refer to as I. It's imaginary. It doesn't actually exist, but we're going to refer to it as I. And the square root of 16, well, the square root of 16 is 4. So we end up with I times 4, or more commonly represented as 4I. So the answer to this equation, as far as Algebra 2 goes, solved over the complex numbers, is x equals plus or minus 4I. And again, you can write it as positive 4I and negative 4I as an alternative way. Okay, in this example, we're going to solve the equation using square roots. We have x squared plus 22 equals -50. Remember, at this point, we are solving over complex numbers. As the point of this lesson is to introduce ourselves to imaginary solutions. So just like normal, though, we're going to go through the process and get rid of any addition and subtraction here. So we are adding 22. So to get rid of it, we'll subtract 22. Giving us x squared equals -72. And then there is no multiplication or division, so we move on to getting rid of our exponents. And the opposite of squaring something is to square root. We're applying that property where we're essentially, not really, square rooting both sides, giving us x equals plus or minus, well, the square root of -72 isn't actually a perfect square. On top of that, it's negative, so we're going to have to break the 72 apart to deal with it. So the square root of -72 will separate it into the square root, -1 times -1 because it's a negative. And the biggest perfect square that goes into 72 is, let's see, 36, yes. 36 is the biggest perfect square that goes into 72, and 72 is 36 times 2. So I've separated into the different factors that will be helpful for this situation. So the square root of -1, as discussed, it doesn't actually exist, but we are referring to it as I. The square root of 36 is 6. And the square root of 2 we can't actually do without getting into a decimal, so we'll leave it as the square root of 2. Overall, if we do I times 6 times the square root of 2, well, I times 6 is 6i, times radical 2 would be 6i radical 2. 6i radical 2 would be the answer. Remember, you can also write it out as positive 6i radical 2 and negative 6i radical 2. And in some cases, you may see textbooks write it in this order, textbooks, some answer keys, and some different resources. May write it like this. I personally don't like this way of writing it very much because this and this, especially when handwritten, are so similar and so easy to mistake with how you write it, accidentally extending that radical sign just over the I, but they're two completely different answers. So I like to make sure I put the I in front of the radical. It just makes it a little easier to distinguish them, especially with handwritten answers.